All right, kia ora koutou. We have just hit 12:30. So we're going to crack in straight into our webinar today. We are in webinar 2 of a 3-part series. So the last one of the series is in a couple of weeks' time, looking at the medical legal perspectives. But today we are looking at the technology advancements within primary care and general practice, and we've got a stellar lineup of different people to come and share their knowledge and their insights and their learnings to date. I'm going to open us up with karakia, and then I'll introduce you to our people presenting, and then we'll get into the day. We do have lots of time for questions and answers, so as the session goes on, please feel free to be dropping in your questions into the Q&A box. And the presenters aren't all presenting at the same time, so they'll be able to reply to some of your questions as we go. Good housekeeping, keep muted if you're not talking. All right, karakia to open. Kia kotahi i ngā pukinga me ngā whakaaro, hei tiaki i ngā whānau mā ngā mahi hauhora, me mahitahi tātou mā te katoa, haumie huie tākie. All right, so we've got on our lineup today, we've got the team from Te Awa Kairangi, PHO in the Hutt Valley coming to talk to us about their learnings, their understandings, and they're also going to do a little bit of defining for us, defining the problem of inbox management, which will be really good. We're then going to roll in to Daniel from East Health Trust. Daniel's GP. He's going to come in and give us the clinical perspective of using digital assistants in general practice. We've got Paul Roseman from ProCare on the line, and he's going to talk to us a little bit more about digital assistants. Him and Daniel have aligned their kōrero to make sure they don't overlap in content, but they'll both bring that kind of dual perspective in there. And then we're going to finish off our webinar today with Chris Patton, who's joining us from Otago University, and he's going to provide a more, I guess, wider overarching view of AI in healthcare. So a pretty impressive lineup for you today of different people bringing different skill sets to the conversation. But to kick us off, we'll hand over to Scott Fisher from Te Awa Kairangi and give your team the reins. Kia ora.
Kia ora, Jess. Thanks very much. I'll just bring up our slide deck. Won't be a minute. Everyone see that?
Kapai. Do you want to put it in presenter mode? Yeah, kapai.
First time, can you tell this is my first time, Jess?
It's just because Grant makes the slideshow so fancy.
Did I get the notes up, Jess?
The second time you shared it, we could just see the presentation mode. Yeah, that's the one we want. You're good to go.
What about the notes in the actual presentation itself?
No, we can't see them.
No, how do I see them?
Oh. Pass. IT support.
Scott, I could share the thing and you just tell me when to change and you'll be able to see the notes on your screen. How about that?
Okay, so let's do that. Sorry, team. E tēnā tātou everyone, aku nui aku rahi no ngā hauewha, tēnei te mihi ki a koutou katoa I tēnei wā ko Waiahau, ko Scott Fisher, tōku ingoa, ko te toi hangarau o Te Awa Kairangi Health Network ahau. So kia ora everyone, I'm Scott Fisher. I'm the General Manager Data and Digital at Te Awa Kairangi Health Network. We're a PHO based in the Hutt Valley. And I'm here with Grant Reid, my colleague, who will introduce himself a little later to talk about and introduce the role of technology in managing your inbox. Today, I want to walk through what we've seen in our practices some of the technology solutions that are being used around the country to combat high inbox volumes. And Grant's going to cover off the role that data will play in helping to manage your inbox. Next slide, Grant. So what are we seeing? So I've only been working in healthcare for the last 2 years, so I can't speak to what inbox volumes were looking like before that, but ever since I've started, the volume of notifications has been a constant complaint for our practices, and judging by the people on this call, we are not alone. So where do these high volumes come from? And more specifically, from a technology perspective, what can we do about those volumes? Next slide. So we know that patients are turning up to general practice with more complex needs, multiple complaints, multiple diseases, and this requires a more thorough triage treatment plans, which includes obviously ordering of new tests, referrals to other services, reports and letters from specialists, repeat prescriptions, etc., all generating a whole bunch of inbox notifications when results come back and discharge summaries are issued, etc. So we know that that's a definite trend. What we're also seeing, next slide, Grant, in our area is, and what we're trying to focus on from a PHO perspective, is what we call excessive communication from external parties. And this is mainly around secondary care. So we are seeing a lot of what we're calling unnecessary notifications being sent through to our practices. And an example of these are ED lab results that were being sent when a patient is being seen by the hospital, specifically in ED. We're seeing duplicate notifications, so more than one notification for the same report or test. So we see that in our area with gastroenterology reports, for example, we receive 3 of those every time one gets issued. We see poorly designed notifications. So an example of that in our area is around discharge summaries. Every update to a discharge summary we get a notification about, but it's not entirely certain or sure or obvious where that notification is or what that update is, sorry. So it takes time to be able to review that particular notification to see what has changed. And then there's a category around unsolicited notifications. So really, if you've got a HealthLink connection, if you've got an EDI, then you are prone, or you have the potential to receive unsolicited notifications coming into your inbox as well. There are obviously other notifications that practices receive, but these are the ones that we've kind of focused on in terms of what we might be able to do something about. So next slide, Grant. So what can be done about it? So in webinar 1 of this series, there were presentations from the likes of Emma and about the workforce and using clinical assistants and virtual doctors, nurses, admins to manage the inbox. We're doing a lot of work in advocacy space around advocating for technology changes with our local DHBs to get them to tune, I guess, the notifications that they are sending through to us, removing the unnecessary and duplicate notifications. So there's a bit of work that we're doing in that space locally with them. Digital assistants, that's something that one of our next speakers is going to talk about, so I won't go into that too much. But the other initiative that we're trialling at Te Awa Kairangi Health Network with some of our practices around what we call a message blocker. And I'll quickly run through what that is. Next slide, Grant. So essentially what it is an application that sits between the HealthLink network and your PMS. We intercept the HealthLink messages, and if they meet a certain criteria, then they will be archived and not appear in the inbox of that particular practice. The request has come from practices, and specifically also our clinical director. They do their own risk assessment on the value that they'll get and the risk that these types of tools or this tool provides. And for those that have implemented it, they are seeing an average of about 95 labs per week coming through, with a total time saving of about 3 to 5 hours a week. So we see this as a temporary stopgap solution, whilst a more permanent solution is in place. And that permanent solution is the advocacy that we're doing with the DHBs. It is a bit slow. So this is our, I guess, contribution in terms of how we might try and reduce the number of inbox notifications coming through. I'll hand over to Grant now, who's going to talk us through how the role of data and how that plays into managing inboxes. Over to you, Grant.
Hopefully everyone can hear me. I'm just sort of fiddling around here, making sure I can get my mic on. You can hear me okay?
How about?
Yep.
Okay, so just quickly wanted to go over with you what kind of data is available out of your practice management system that can actually help you get to grips and understand what's going on in your inbox. And so we'll start with that, and then I'll just give you a few ideas about what we think you can do with that information as well. We for Te Awa Kairangi, we are just on the cusp of actually getting a new data sharing agreement signed up with our practices that will actually allow us to do this officially. So what you're seeing is sort of like our preliminary sort of findings here. So we know we can do it. We're just waiting to get the official sign off for pulling this data, and then we'll be able to share it back to our own practices. So the first thing that you can get, and this little sort of chart here is just based on some sort of some initial findings, so it's kind of fake data, but just sort of illustrates what you can do. The first thing you can get out of your PMS is you can get all of the inbox counts by subject or category, whether that be like complete blood count or radiology, or even right down to the whether or not it was a scanned document. So you when you look at a real practices data, you can actually see the 50 or more different categories of inbox items that you're able to drill down into and see how many have arrived. And of course, you know the date that they arrived as well. Also, this finally moves for me. Also, you're able to see the inbox counts by the sender, effectively, the source. So here's some examples here, Wellington SCL, one of the prominent labs here in our region, and Pacific Radiology, or COVID, or bowel screening, or any of the providers that are regularly sending through things into your PMS. You're actually able to break down the volume that is arriving from each, which is really, really kind of useful. And then finally, and I don't really have any sort of data to show you, but the other really interesting thing you can get out of the PMS is that for every item that arrives in the inbox, you get the date that it arrived, when it was created. You get dates when the status is changed in the PMS, and you get a date when it's filed. So if you use maybe filed as, depends on how your practice does things, but if maybe the last thing that happens to an inbox entry is to file it when all the work is done, or it's been completed, then you're able to get a really basic idea of roughly how long it took for that inbox item to be actioned completely and done. This is quite a useful thing because you can do some other interesting stuff with that later. And that's available for every single inbox item. So the kinds of things that we recognize and we are intending to do with this is, in dashboards that we'll play back to an individual PMS and keep an eye on things from a PHO level, is understanding what the sort of seasonal trends are for incoming inbox work. And you can see on the dashboard on the right hand side here, I've just sort of like I think it's daily, yeah. Oh no, it's weekly sort of counts. But you can go back you can have a look at a day or intraday, or go back over a whole month. You've got all that you can collect all that data, and so that sort of gives you a feel for when do we typically get busy in a year or in a particular month, or are there any sort of like phases where we see a larger amount arriving of a particular type? You can draw all that kind of stuff down. So that's, that's quite useful for a lot of reasons. But, if you start building up a baseline of what things normally look like, you can start looking for sort of behavioral or system changes, which is particularly useful if we're looking across a whole bunch of practices. And the other thing that you can do is, if you're doing a lean initiative, then one of the things they recommend that you do is that you collect data before you make your improvement, then you collect data after your improvement to see whether or not it had the impact that you expected it would. So that's something that we have done ourselves. For instance, with the inbox blocker, we were able to sort of collect information, and we were, we expected the amount of emergency department ordered labs to be much higher than they were. We went and built this thing. Had we known, maybe had we known the actual volumes, maybe we would have done less work when we built that. We built that system. We may have invested less. So it's really, really useful to have these things up front. And a huge benefit of having all this data too is that, particularly in the work that Scott's been doing with the DHB, is having, when you're advocating for improvements to the system, being able to give them the numbers speaks so much more to someone than someone who is arriving with an opinion, effectively. So that's a massive help. So here's one of the more interesting things I think we can do too. So what we have here is, say the volume on the left-hand side of a particular category of incoming inbox items. And then on the bottom here, we have an average time to file. So you could do something quite interesting like this. Obviously, the ones where you have a high volume and take your practice a long time to file would probably be a target of your initiatives first, because they have the highest impact. And obviously the ones down here where you get a lot of them, but they're turned around really quickly, is probably not something you'd care so much about. So this kind of thing allows you to plan initiatives and target initiatives that they have the highest impact. Maybe do some resource planning around being able to, if you're planning with your clinical assistants, what kind of skills do we need them to have? I don't know about that one, but this kind of thing is possible. And it really, and just in my example here, is like, obviously, for pulling the data that we've got out of the PMSs, we know what our next target is going to be, and that's around the way that document scanning is handled, because we know that is a big overload for some of our practices based on some of the data that we're seeing. So these are some of the ways that we see data being applied, and that's been our overview of the space from our perspective. So Jess, we'll hand over to Daniel.
Yeah, kapai, thank you, Grant. That was awesome. And kia ora, Daniel, straight into your presentation.
Tēnā koutou, ko Daniel Calder toku ingoa. I'm a GP working in a low-cost access clinic out in East Auckland, and I'm also clinical director of East Health, which is a PHO up in Auckland. So we do use digital assistants, and I'll bring up my slides, but I want to talk a little bit about our experience, what's working well, and also signpost some of the challenges. So I won't labor this point, because I think Scott and Grant have done a fantastic job in terms of quantifying the issues and also highlighting it in a numerical way, which I think is really helpful. But just have to say, as a frontline GP, I'm seeing this all the time. The volume's just going up year on year. Now, when we talk about digital assistants, we sometimes also use automation as a term, but essentially what it is a bit of IT that can take over some of those really repetitive tasks that we're otherwise using highly skilled clinicians to do. And when I'm talking about clinicians, I'm thinking of not just the GPs, I'm also thinking of nursing time in this as well. So it's taking away some of those routine tasks. It's extremely rules-based. So I think it's important to separate what we mean between digital assistant, as what we're currently using in some of our clinics, and artificial intelligence. I think there will be a space for artificial intelligence in future, but currently it is essentially following a complex set of rules. And if you think about how your Outlook emails can be set up, you can put in forwarding rules, you can have automated replies that are going out. What we're doing with digital assistants is more similar to that really than artificial intelligence, certainly at this point. Now, I'm putting this up not because you have to sort of memorize and read every bit of this slide, but it's just trying to conceptualize the steps that a digital assistant goes through. So this is a simplified diagram, and in reality, there's many more steps that are taking place. Now, what I thought would maybe be of interest is just showing a very short clip. It's just over about a minute, and it actually shows how the digital assistant operates, and I can talk through those steps. So if we're getting the technology to work, it should start here. So we use Indice as a PMS in the clinic that I work, and you can see that it's logging in the same way that a human would do. And then this is just a landing page that it hits. Now, we do need to put pauses in the system to allow for the PMS to catch up. So that's part of how you configure the digital assistant. Now it's in the inbox, it's selected all inboxes, so it would be for all providers, and it's looking for specific predefined search terms. So this particular assistant is working on bowel screening results. And we've just blacked out names and things, but you can see this is a screening fit test, and in this case it's normal. So it's going into measurement, or what in medtech would be called screening. And then putting in the correct provider, and it's also putting in the screening or measurement term, looking for the correct outcome that it's learned from the document, and now setting the recall as well. And all of this is work that quite often our nursing colleagues are otherwise doing. So this unlocks nursing time that they can use with patients rather than being stuck in the screening mode. Okay. So currently we've been really focused on digital assistants working around a screening space, and these national screening programs being high priority. But we've also got COVID digital assistant, which has been really helpful because of the volumes that we saw during the peaks of COVID. Now there's less testing, there's also less results there. But that's what we've got currently. Now, areas that we're interested in would be expanding to retinal screening, doing CVRA assessments, those cardiovascular risk assessments, but also some of the noise in the system. So coming back to Scott and Grant's work that they've done, there's a lot of messages that we probably don't need anyone in the team to look at all. And in some cases, having a blocker, which sounds very attractive to me, would be the solution. In other scenarios, we might use a digital assistant to actually just auto-file some of those messages. Now, just quickly go through some of our experience in this space. It's really important to plan it out carefully. So you need to look at, what are the steps that a human person would currently do, maybe optimizing some of those steps, because it's going to be critical that you've got a clear sort of diagram or overview over each step before you expect IT to take over. If there's current issues with how the clinical team are handling a specific type of document, then that would become an issue for the digital assistant, clearly. Then there's quite a lot of testing going on before you go live. So we need to have confidence that the IT does what we would expect it to do. And we've got it set up in such a way that we can run the digital assistant without actioning the different documents. So you don't file, you don't set a recall, but a digital assistant will create a log and tell you exactly what it would have done, and then we can go live after that. It is important to have good audit of everything that happens, so that we can give clinicians confidence that the system works in the way intended, but also if there should be a problem that we can go back and rectify. I have to say, I mean, I've got lots of different ways that I'm trying to manage the growing admin burden. And we've tried a variety of different roles within the clinic. I mean, I think a digital assistant, it's not the only solution. I think we're probably looking at a range of ways that we can reduce things. But if you compare to a human, certainly it's the case that a digital assistant doesn't get tired, so they can continue working day and night, 24/7. And it's also very predictable. So as with a human, you can actually expect it to be human error at times. With the digital assistant, I have to say that the only times that things get out of hand will be, which I'll come on to with some of the challenges, if something sits outside of the rules and the digital assistant actually just stops, leaves that document and moves on. So I haven't really found that there are errors as such. It will be that there'll be something that has changed that we then need to accommodate for. So I will briefly mention some challenges. There is a phenomenal amount of time that goes into developing a digital assistant. The clinical side is not the time-consuming step. I would say it's the IT development that is the rate-limiting step. That's where it really takes a long time to set it up. You can't just set it and forget. You do have to have someone monitoring and at least looking at exception reports, because things can crop up. And when the PMS vendors change things in terms of how they have the setup and screening of measurements. So for instance, with the HPV self-swabbing that has come out, that has changed a few things. That means that the digital assistants need to be tweaked to accommodate. And then we have to think about how the sender can influence how the digital assistants work as well. So I'm thinking of, the labs, radiology, hospital colleagues. If they change the way that the document is set up, for instance, if we've got a routine type of document and then suddenly they start adding free text commentary to that, then that's something that we need to look out for and tweak in terms of how the digital assistants work. So in an ideal scenario, what we would have is more use of standards where we don't have those surprises, I guess, from Te Whatu Ora. And I do think that digital assistants can play an important role in reducing clinician burnout. I think we're only scratching the surface at this point, but I am absolutely convinced that this is something that will come and become, just standard way of operating in GP land soon. I think that we need to just continue progressing it, and I know Paul will talk a bit about what they've done in ProCare as well, and I would just welcome other PHOs to come on board as well. I think that it's challenging for a single clinic to do this because of the investment in time, and I do think that PHOs can have a very strong role in supporting their respective clinics and seeing some progress in this space. Thank you. Hand back to you, Jess.
Kia ora. Thank you, Daniel. That was awesome. So good to see the bot in action. All right, I'm going to share Paul's slides, and Paul's gonna, hopefully you can see them beautifully over there. Paul's gonna kōrero to them. So over to you, Paul.
So Jess, thanks. Kia ora koutou, everybody. Ko Paul Roseman, Toko Ingoa. I'm the GM for Strategic Development at ProCare. And as Daniel and everybody else have said, we've been playing around with digital assistants in a very, very similar way to how Daniel outlined. And like East Health, we've got a suite of robots that work on the inbox. But because Daniel's already talked about all of that sort of stuff, I thought I'd show you what we've managed to achieve with cardiovascular risk screening. So this is a little bit different to managing an inbox. It's really about managing a proactive task that is clinical in nature and would have otherwise consumed a whole lot of time of people in the practice. Yes, can you just move on to the next slide for me, please? So again, like Daniel, you're not supposed to be able to read this, but we do follow a similar process to what East Health talked about in terms of the process for developing a robot and the clinical criterion decision making for writing the specific robot. So we've got a generic framework for how you develop one, and then a specific process flow that each robot is following. And this is an example of the CVD risk one. And as Daniel mentioned before, this is a summary of it, not the full detail of what's going on in there, because there's a lot of very, very micro decisions, like if you're picking up a weight measurement out of a PMS to use it in calculating a cardiovascular risk, how old is the measurement? You've got to set a guideline for when a measurement is too old to be picked up and used. We note here that to err is human, but to really foul it up, you need a computer. And the reason that we note that is, as Daniel pointed out, the robot is very, very predictable in what it does. And it needs to be, because people are way less forgiving of mistakes that the computers make than mistakes that the robots make. And to give you a real life example of that, when we launched the CVD robot, we had feedback after a month or so from one of our practices who called us kind of a little bit panicked, going, "Oh my God, the robot's made some terrible, terrible mistakes here. It's calculated a couple of risks, as it happens, with weights that were too old." And we went, "Oh my gosh, that's terrible. Let's look into that." There were actually 3 of those results that we found in that practice's PMS. And to be fair, the robot had made one of the mistakes, but the other 2 were actually made by humans in the practice. So mistake was the same. Cause of the mistake was twice human, once robot. Robot was the one that got the blame for them all, though. And the beauty of it is we could correct for the robot so that it won't make the mistake again. Not sure we can say the same about being able to correct for the human mistake in quite the same way. But yeah, it's important to note that you do have a heightened sense of accountability when you're using technology to do these things. Jess, can you move to the next slide? So we are going to talk about the CVD robot, but the way this flows is it really does start as was benefit to the practice. And we've talked about this. Key benefits to the practice are around time saving, and that time saving either enables other work to be done, or it provides that improved work-life balance. So with our CVD robot, we've deployed it across, actually it's across 16 practices now. It was doing around about 1,200 risk assessments per week. That's a little bit like Daniel was saying around working 24 hours a day and not getting tired, not taking work breaks. Is roughly the equivalent to around about 3 or more FTE nursing time in terms of the work it was doing across those practices. Next slide, please, Jess. One of the most compelling reasons to continue doing this is when you talk to the clinicians, and I've talked to a number of the clinicians. I haven't found one yet that said, "Take this thing away, it's a dumb idea, let's not do it." But you do get comments like this: "I love my robots." You really miss them when they're offline. And the thing about them being offline is the way the technology works, as Daniel pointed out, is it does mimic a human. So it can only be working in one place at a time. And so it pops out of your practice and pops into another practice to do some work there. And in doing so, what it is actually doing is sharing the nature of the resource. So you don't all have to buy the server capacity, because we can get through the work across practices with shared server capacity and shared computing power running the robots. That leads to a whole series of possibilities around scheduling and pairing up robots to use the same servers and all that sort of stuff. And that's a really good reason for having a collective approach to this, to get the most value out of the investment in both the development of the robots and the deployment and operation of them. Next slide, Jess. And just hit the button again. The particular one that we've dealt with and we're talking about here is cardiovascular risk assessment. And an important practice benefit is improving clinical outcome and population health. And it does this two ways. It either does work that hasn't been previously done, and you can see that marked on the graph there for this particular practice, where there's quite a marked improvement in cardiovascular risk rates around the launch of the robot. And so what's going on there is the robot's doing stuff that the practice didn't have time to do. And so that's fantastic, because that gain is an immediate health gain for the population concerned, and it's a relief to the practice concerned that this work is now done and it's not sitting there waiting to be done by people. But having done that work doesn't mean you should now turn the robot off, because all of the underlying work that was achieving the baseline work was being done by a human, and it's entirely possible that that can be done by the robot instead. So it's not just about closing the gap, it's actually about taking over some of the work and releasing that time back to the practice to do other things. And what I think is really critical here is when you're running a thing like a cardiovascular risk assessment, all that time that it takes to produce a risk assessment, and I'm sure clinicians will argue with me on this, but where that risk assessment turns out to be normal, that time effectively hasn't changed the health outcome for anybody. It only changes the health outcome for somebody when you find that the result of the risk assessment is a high cardiovascular risk, and it leads you to do a clinical intervention with that person that changes their future trajectory of healthcare. By having the robot do all of the work of finding who needs to be worked with, you've freed up all of the time to actually work with the people who have the high risk and have a greater emphasis on producing change and improving health outcome. And I think from a health perspective, that's the place where the robots are adding the most value, by giving you more time to spend changing people's health outcome rather than spending time finding the people who you need to change health outcomes for. Next slide. So a really important component of changing health outcome is contribution to equity. And I know we're all really focused on health inequalities across the motu here. And so we took a close look at whether this actually did contribute to equity doing this work, because there's always risks that technologies are preferentially applied in environments that drive increasing health inequality rather than reducing health inequality. So just tap the bar again, Jess, please. What this graph attempts to show, and I'm having to read it quite carefully on my phone at the moment, but what it shows you is if you look towards the top of the stacked bar charts here, you find more pink, purple and orange in our Pacific, Māori and other Q5 populations than what you do in the non-high needs population. So that's the non-high needs population, if you can't read it, is bar graph on the left, and then Pacific, Māori and Q5 non-Pacific, non-Māori as you move towards the right. And so because what you've identified here preferentially is populations with higher cardiovascular risk, and you've realized time through the robot offering, finding these, you've created the opportunity to close an inequity gap. So we consider this as some proof that this technology actually has the very important ability to contribute to reducing inequalities by getting risk scores done on populations that are not otherwise having their risk assessments done, by promoting that those people are at higher risk, are preferentially in those groups. And not surprisingly, I guess to many of you on the call, a lot of our highest needs practices are the ones, courtesy of our capitation formula, that are often under the most pressure. And so the robots get to do the most work in those clinics. So there's kind of three ways that the robot is contributing to equity here. It's working in the high needs practices that are under the most pressure. It's doing the most work there, and it's finding the most candidates for clinical intervention to reduce risk. So we think in those three ways, it's actually supporting the achievement of equity. Next slide, please, Jess. So I think Daniel's already touched quite a lot on this. Should you do this yourself? Well, the short answer to that is it would be way better if we did this together. So the things that you need to think about is the work that you do, is it scalable? Will you be able to keep it going? Will you have additional license and infrastructure costs because of what you want to do yourself? Will you have a consistency of PMS environment? So how often will you have to change the robot? And Daniel talked about that because of changes to your PMS environment. As I talked about forgiveness in the environment, we think that governance is really important. You've got to have a really strong quality process to avoid making a mistake, because if you make a mistake in the robot, it will amplify it across all of the work that it does. And as with everything, there's opportunity costs. The time you spend doing this is time you don't spend doing something else. And so the more we can be efficient in the way in which we develop the robots and use them, the more opportunity there is for others within our environment to be thinking about other things that we could do. And like both Scott, Grant, and Daniel, we think this is a way that you can improve quality and improve efficiency and sustainability, but it's not the only way, and we all need to be working on different ways of doing this stuff. So I guess our plea would be to say, look, let's work together. For organisations that want to get involved in this, let's work together. I think there's an important caveat that hasn't been explicitly stated, and that's that in our current environment, our best experience is with the industry practice management system. Our experience with the other practice management systems is not as strong, and if I'm being brutally honest, has not been as easy. But we are continuing to work away at that and see what we can manage to achieve. Jess, I think that's it for me. There is a closeout slide. If anybody wants to get in touch, you can get in touch with Amy at ProCare, but you can also get in touch with me, and my email address is even easier than hers. It's just paul@procare.co.nz. Back to you, Jess.
Kia ora. Thanks, Paul. Just a little prompt for everyone to pop your questions into the Q&A function. We do have the presenters online who will be able to answer them as we go, and we will have a little bit of time at the end for questions. But in the meantime, we're going to hand over to Chris to bring us home with healthcare and AI and share some of his whakaaro. So over to you, Chris.
Thanks, folks. Kia ora, I'm Chris Payton. I'm a medical doctor by background, but work in research and teaching in digital health. So I teach a postgraduate diploma in digital health for the University of Otago, and I've been working for the University of Oxford for about 13 years or so, and have a research group there. And we work mostly in Africa and in Vietnam on digital health projects. So I'm just going to give a bit of an overview about, I guess the reason for asking me to come along was because the kind of future of these digital assistants might be AI-based digital assistants. And before everyone kind of jumps on the AI bandwagon, I'll just give a bit of an overview about what people are saying about using AI in healthcare internationally, and give a bit of background about what AI is when you might get kind of sold a solution that is AI, just so that you know a bit more about it. So the kind of traditional idea of AI was to try and make computers that can make kind of decisions in the same way that humans can make decisions. And this started off by trying to do create algorithms, which is called symbolic AI. So kind of like those kind of pathways that you saw in one of the earlier slides. This is also often called good old-fashioned AI, or GoFi, or expert systems. And it's basically if-then sequences based on human expert reasoning. And you could probably say that some of those kind of personal assistants qualify as this. So the programmers will talk to experts and then use the answers from the experts to create a kind of algorithm that the system then follows. And usually these are based on structured data sources. And so these are in quite widespread use. So for example, 111 in the NHS, their online service, uses this kind of if-then sequence to help people with their symptoms and knowing where to go. And you can kind of download symptom checkers and things like that, and drug interaction alerts and clinical decision support systems and that kind of thing. But more interesting, I think, is machine learning, which is the kind of more modern use of AI technology. So this is the idea that if you want machines to be intelligent, perhaps we should take inspiration from something we know that's intelligent, which is the human brain, and basically build a simulation of how the human brain works. So artificial neural networks, which are used for machine learning, they're basically copies of how neurons work in the human brain. And you have a network of neurons that operates in the same one. So the strength of the signal going into the neurons determines whether or not it fires, which is the same as how the kind of human brain works. And you can see this kind of video on the right. This is kind of one of the early demonstrations of machine learning, where you give the system, the neural net, the pixels of a computer game, and it can move a paddle from left to right, and it knows if it's doing a good thing based on the score going up. And just by reading those pixels, not even understanding anything about them and not understanding anything about how the paddle moves, over time the network gets trained to be able to play a computer game. And again, these systems are quite widespread use nowadays, so they're used for interpreting radiology films and things like that. So basically what they're doing is they're simulating a small bit of the human brain, like the visual recognition system for patterns, and putting that in a kind of digital version. And those seem to be quite effective. Quite a lot of AI companies in healthcare will use machine learning for things like language recognition, so for kind of chatbots, and then plug into something like the if-then sequences on the NHS pathways to give the kind of more kind of clinical data. So the AI might not be a kind of clinical AI, it might be like a general purpose, like image recognition or chat, and then plugs into a kind of more old-fashioned type of AI. So our research group in Oxford, we've been doing some work on this. We've got a smartphone app that uses video from the smartphone to detect heart rate and breathing rate, and this is using machine learning technology developed in the engineering department at Oxford, and we're trialling it with partners in Kenya, the Kenya Wellcome Trust. And also working in Vietnam, where we're looking at things like lots of different projects here, but looking at things like can we use pulse oximetry raw data, so not just the number from the pulse oximetry, but actually the wavelength, the PPG signal, to do risk scoring for patients on ICU, and also doing things like image recognition and other things. So the really interesting thing, I think, and this is what I kind of wanted to talk about and maybe just open up for questions really, is about these new types of AI that everyone's talking about, these kind of chat GPT approaches. So this is again using machine learning, so using those kind of artificial neural networks, but instead of doing like a small bit of what the brain does, like recognizing an image or processing audio or something like that, it's really trying to have the whole brain, so operating like a human would operate. And this is called artificial general intelligence as opposed to narrow AI. And there's been a number of companies trying to kind of crack this. So they basically want to build a full simulation of a human brain rather than just focusing on a specific task. And so these companies are things like Google DeepMind, Keen Technologies, Anthropic, Stability AI, and OpenAI is probably the most famous. And they've been having a lot of success recently. And I put here that there's been a letter to pause this kind of development because it's so dangerous and so powerful. So there's been quite a lot of discussion in the press that people will have seen. I thought I'd just give a bit of background for OpenAI because that's the system that is currently the main one that's being used. So OpenAI was founded because they thought a group of kind of technologists in Silicon Valley thought that unaligned artificial general intelligence could pose substantial risks to humanity. So that's this idea that AI might become self-aware, might be much more intelligent than human beings, and be able to manipulate human beings to give them all your money, or take over companies, or get involved in military operations, that kind of thing. So Elon Musk and Peter Thiel, who I think is a New Zealand citizen now, he's the person who funded Facebook, And Elon Musk, people probably know him from Tesla and SpaceX and bought Twitter recently. So they set up OpenAI as a non-profit to try their way of stopping AGI kind of taking over the world was to make it open source. So that's why OpenAI is called OpenAI. So they wanted to build models but make them open to everybody to use. And they worked with a guy called Sam Altman, who is his background is as a kind of cryptocurrency founder. So he set up this thing called WorldCoin, which uses this orb to scan your retina. And then if you allow someone to scan your retina and store it on his servers, then they'll give you a kind of cryptocurrency coin. And it's a way of doing kind of knowing whose currency belongs to who, that kind of thing. So anyway, they hired lots of really great AI experts and created GPT-1 in 2018. And that basically was a new way of doing kind of text prediction. What they did is they gave it things like Wikipedia and give it the first bit of the sentence and then say, so, okay, you've got to guess the next word that's going to come up. So if you say like Johnny kicked the ball down the road and then it got to come up with a plausible next word and a plausible another word. And they could see that by training this on AI, not only was it just being able to predict the next word, but it was the reason it was able to predict the next word is because it was building a model of how the world works. So it's actually understanding that there's a boy and he kicked the ball, and if you kick a ball, it rolls down. And that's because it's trained on all the data from books and Wikipedia and things like that that describe how this is. So they can work out what language is and what it means, and then it's starting to build this kind of model of the world. So it's similar to how the human brain works. About that time, there's a guy falling out in the company, and Elon Musk left, and Sam Altman kind of took over, and they changed from being open source to closed source, and they also changed from being a non-profit organization to being a for-profit company. They released ChatGPT, which people probably know about, which is this very capable chatbot that uses this kind of world model to produce text. And then more recently, they produced GPT-4, which was a huge model that is extremely powerful and works really well at generating very good text. So that's just kind of background of that. I won't go into too much detail about this, but people are thinking about how can we use this in medicine. There was a study that showed that if they put in answers that people were posting, put in questions that people were posting to a social media forum that was moderated by doctors, the responses from GPT-4 were better than the responses from the clinicians who moderated the forum. And the panel of experts who reviewed these said that the chatbot responses were rated significantly higher for both quality and empathy. So it's kind of kinder as well as more kind of clinically effective. So there's a bit of debate about whether or not GPT understands the world, and that's why it can do such great answers, or whether it's just really good at kind of guessing what would be the best kind of what people expect. And I think most people now think that it does have an understanding of the world, and that's how it's worked. So it's working the same way that the human brain works, essentially. And the reason for this is because as these models get bigger and bigger, they get more and more similar to how the kind of human brain is structured. So the human brain is quite simple, really, when you go down microscopically. The neurons are the same and they connect in the same way. It's just a very complicated network. And there have been studies by Google and Microsoft that kind of seem to indicate that as these networks grow to a significant size, they generate new abilities, like the ability to reason and understand the world. So lots of people are discussing this. This is a colleague of mine at Oxford who talked really about they might be really good at diagnosis and for making suggestions about what to do, but a lot of healthcare is really about caring and about looking after people and that kind of human emotional connection. So unlikely that AI is going to be able to do that in the near future. There's a lot of risks involved with this. The way these models are trained and work is that they guess and they make things up, and that's how they kind of work. And you can never really tell if it's making something up that you haven't figured out that it's making it up, or whether it's actually true, and there's not really a good way of telling it. So Te Whatu Ora say we can't use these types of systems yet because of that, and also because of the worries about where the data is going, particularly in terms of things like Maori data sovereignty and things like that. We don't want to send data over to servers in other countries. Other countries are similar approaches. So MHA in the UK says don't use LLMs for medical purposes. They're classified as medical devices and need to be regulated like medical devices. And World Health Organization, FDA, other people, and I spoke at a G20 summit talking about this a bit. And around the world, people are aligning the idea that AI systems in healthcare should be regulated in a similar way to medical devices in the short term. So I won't go through that to you because I think we've only got a few minutes left for some questions. So there's lots of guidance on how to do this properly. The UK in particular has done lots of guidance on how to evaluate and regulate AI. So I won't go into too much detail. The FDA are drafting regulations at the moment. And in New Zealand, I'll just skip through. Oh yeah, New Zealand, there's a new therapeutics products bill where they'll classify software as a medical device, and it will probably be similarly evaluated by them before approved for use. There's a bit of a discussion about whether classifying them as medical devices are appropriate. I kind of think it probably isn't, and that they're quite different from medical devices. But that's a debate that's kind of ongoing at the moment. One of the things just to bring up is a system called NABLA, which I think a lot of GPs have started using. And just to highlight that that does use a large language model, so it uses the GPT-4 model, and it will send data to OpenAI servers to create their outputs. They have a process of pseudonymization, so they try and remove names and identifying details before they send it, but I think that is an automated process, and I haven't seen any evaluation of how accurate that is. I had a little try with it. It seems pretty good and pretty effective, much like ChatGPT is for lots of things. And I gave it a case and it kind of made up some instructions to send to a patient. Yeah, like I say, because it uses an LLM, it probably is not something that should be used presently, given the Te Whatu Ora advice. But happy to take any questions on that, or if there's no time for questions, you can send me an email. Happy to discuss with anybody. Okay, I'll stop there. Jess.
Kia ora. Thank you for sharing, Chris, and yeah, highlighting some of the really crucial elements of AI in healthcare, which I'm sure are top of mind for everyone. We do have a couple minutes left. If anyone's got a kind of pressing question I'd like to ask one of the panelists, feel free to raise your hand and we'll come to you. Saya. Just checking the hand button worked. There was a little bit of discussion in the Q&A about other PMSs, and I've just responded in there that we are actively advocating for our colleagues at MedTech to enable some of the digital assistant work to be compatible across there. So there's a lot of people having those conversations. So if you're on a MedTech system with a bit of FOMO, we feel you, we understand you, and yeah, we'll definitely be working with them to see if we can build a solution with them.
Yes, Jess, I was just wanting to know where the place of PIAs are, that's privacy impact assessments, are in particularly the use of NABLA, yep. But also in the use of other LLMs, and where we are with that, and what the college is saying about its use, as some GPs are already using it.
Yeah, awesome. I think that will be a great question for the third webinar series, which we're looking at the medical legal risks and perspectives, where we are co-facilitating that with the college. Dr. Luke Bradford will be chairing that session. It will be run as a panel session. So we will look at some of the college advice in that space. From a PHO perspective, I might just hand to Scott, chair of our data and digital leads group, to provide a bit of commentary.
Yeah, thanks, Jess. So Te Whatu Ora have recently issued some guidelines around the use of GenAI, and so essentially their stance at the moment is not to use it when it involves clinical information, similar to what Chris has just said. Obviously each individual practice is an entity within itself and has the ability to make its own risk assessments and clinical assessments about the safety or otherwise of any product, and that includes Nebula. There are practices out there that have been using it for months now, and they've obviously done a risk assessment, and based on their risk tolerance, they've decided to go ahead and use it and see that the benefit of using this product outweighs the risk of using it. And there are other practices down the other end who are wanting to use it or investigating the use of it, but don't really know how to quantify the risk. From a PHO perspective, my view is how do we, as a PHO collective group of PHOs, come to an understanding, a collective understanding of those risks and be able to represent those back to our practices nationally, so that contributes to the risk assessments that practices can make when thinking about whether that tool is suitable or not. So that's probably the conversation around Nebula. And then the other conversation is what if other AI products keep coming on the market? What is the capacity and the ability to continue to almost certify these types of products for use? And I think that's a bigger question that no one really has the answer to at the moment.
But also a very key part of GPNZ's advocacy moving into 2024, looking at that accreditation and the, I guess, approval of some of these vendor products that are coming available. So to Scott's point, I'd lean into your PHO. If you're unsure on what the advice is, lean into your PHO. There's been lots of discussions been happening at our data and digital leads hui on this. Grant, you've got 10 seconds, and then I'm going to close us out with karakia.
Okay, I just wanted to add, if you're thinking about a product like this, it's not just the PIA, it's also the security around the information that is being sent to it. It's the equity elements of it, and not just data sovereignty, but whether or not it can handle elements of, Maori language or things like macons and stuff like that. So, when you're looking at it, you need to look a bit broader than just privacy, and as well as also the risk of using something that is capable of making stuff up, like a large language model, like Chris has already sort of hinted at. So it's more complicated than almost any other technology decision that you would make.
Kia ora, thanks, Grant. If you do have any other burning questions, feel free to email them through to me and I can get them out to the panelists for them to answer. We will be sharing the slide decks at the end of the webinar series. So we'll kind of pull together all of the resource from all 3 webinars and then kind of supply it back out to everybody as a toolkit. So unless you're burning to have a copy of something beforehand, please hold fire till Wednesday fortnight. The 22nd is when we've got the last of our webinar series, and then we'll publish that entire toolkit there. The recording for these webinars will be up on the GPNZ YouTube channel, which you can just search up on YouTube and you'll see the series in there, and we should have this recording up within the next 48 hours. But on that note, trying to keep to time, we'll close us out with karakia, and we'll see you all on the 22nd of November for the medical legal one, where we've got a pretty robust discussion happening across from an independent lawyer, from the medical council, from the college. We've got MPS also attending that session. So we're really excited to kind of see what comes out. If you've got some questions that you want answered in that session, feel free to email them to me. I'll be collating them over the next couple of weeks. And finishing our session with karakia. Whakamaua te kōrero, whakamaua te wānanga, whakamaua kia rangi nui e tū iho nei, whakamaua kia papatuanuku e taku tō ake nei, whakatina ki te tungu o te maramatanga kia tina, tina, hui e taeke. Ka kite koutou. Thank you for coming along.